Hello guys, welcome to module 7 of advanced Python concepts. So in this module we are going to learn about iterators and generators, and we are going to look at yield statements, and part 2 we are going to look at decorators and meta classes. Whereas on part 3 we will look at context managers with using with statements. So with context manager, I know you have some idea on file handling just on previous module on module 6. So if you haven't watched more about context manager, please rewatch module 6. And number 4, we will look at multi-threading and multi-processing. And finally, on part 5, we look at asynchronous programming using async and await keywords. So stay along as we move on pragmatic section. Hello guys, and welcome to module 7 of advanced Python concepts with expanded explanations. So in this module we wanna cover the following: iterators, decorators, concurrency, and metaprogramming with in-depth examples or explanations and production ready examples. So part 1, we're going to look at iterators and generators. Iterators versus generators. So let us look at their differences. So iterators are objects that allow you to loop through data one item at a time. So to be an iterator, an object must implement two special methods, and these are underscore iter, and which returns the iterator object itself, and part 2 is that underscore next underscore which returns the next value and raises stop iteration when completed. So note, you usually write a full class to create a custom iterator. So let us move to generators. So a generator is a simpler and more concise way to create iterators. So you write a function and use the same function. In this case, we're referring to yield keyword instead of return statement. And each time the function runs, it pauses at yield statement, which remembers where it left off and continues from there when called again. So there is no need to write underscore iter underscore or underscore next underscore manually, since Python handles that for you. So remember, both iterators and generators have the following similarities. They enable lazy evaluation, meaning values are produced only when needed, and this makes them very memory efficient, especially when working with large datasets. So use case example: if you are looping over a large file or generating prime numbers, like in our class, using an iterator or generator helps avoid loading everything into memory at once. Hello guys, let us look at custom iterator protocol. So we have example class prime iterator. So we want to create an iterator that yields prime numbers up to a specific limit. So we define underscore underscore init underscore underscore with two parameters, self and limit. So we set the upper limit for prime numbers. Now self.limit is equals to limit. So we start checking from the first prime number, and self.current is equals to 2. So we define underscore underscore iter underscore underscore set with self parameter. So we return self. So an iterator must return itself as an iterable. So we also have a method underscore underscore next with self parameter. So while self.current is less than or equal to self.limit, so we must continue checking if the number is prime number until the limit is reached. So if self.is prime, self.current, so we check if the current number is actually a prime number, and then prime number is equal to self.current, which means we save the prime number. In self.current is plus 1, so we move to the next number if the current number is not a prime number, so we return prime. So this one yield the prime number. So, and remember self.current plus 1 if not prime, so we move to the next number and we continue. So we raise stop iteration if we reach the maximum number or maximum limit. So if limit is exceeded, we need to stop iteration, in short. So we also have a method is prime, so self and number. So, and this helper method will help us to determine if a number is prime, and if num is less than 2, so we need to return false, so which means zeros and 1 are not prime. So for I in range 2 comma int, we need to do a square root. So we only check up to the square root of n for efficiency. So, and if n percentage I is equals to 0, then we need to return false, which means it's not a prime, or if divisible by n number in that range. So we need to return, else we need to return true. So to make sure that to confirm, else we need to return true to confirm that indeed it is a prime number. Now let us look at example usage. So for example, you need to print prime numbers under 20. So for prime in prime iterator 20, so we need to print prime, and our output should be 2, 3, 5, 7, 11, 13, 17, and 19. So pi advanced python concept.py, and we find that our output is are 2, 3, 5, 7, 11, 13, 17, and 19, as we just expected here. So guys, you can do examples and test your outcome. So let us move the next section. So guys, let us look at generator function. So example, define sliding window with sequence and size as parameters. So this one is a generator yielding sliding windows of a given size. So for example, sliding window A, B, C, D, E, F, G, and with 3, which means A, B, C, B, C, D, and C, D, E. for I in range length of sequence, so minus size plus 1 is such that yield. So guys, don't be overwhelmed. I will just explain the above function. So let us connect with this memory efficiency processing of large data sets. So for example, DNA sequence is equals to A, T, C up to G. So for window in sliding window DNA sequence, and we need to scale it into threes. So we need to print processing code and then window. So guys, let us just look at summary of what has just happened. So this code or the above code defined a sliding window function and demonstrates how it can be used to process parts of a program. So for example, sequencing efficiently, especially useful for large data sets like DNA sequences. So let us have some notes here. Generator expressions. So generator expressions are concise. They have concise generator syntax similar to a list comprehension, and they use parentheses instead of brackets. And let us look for example, x star x for x in range 10. So this one creates a generator expression that computes the square of each number from 0 to 9. Remember, Python indexes from 0. So this is memory efficient compared to a list. Yes, it's efficient compared to a list comprehension because it yields one item at a time. So print sum of squares. We'll get the sum squares. Then the output should be 285. So this calculates the sum of the generated squares and prints the result as the output. So and this one is equivalent to 0 squared plus 1 squared plus 2 squared all the way to 9 squared, and we get the output as 285. So part 2, let us look at decorators and meta classes. So decorators and meta classes in detail and with the explained in simple terms. So decorators. So what is a decorator? A decorator is a special function that can modify or extend the behavior of another function or a method, so without changing its actual code. So decorators are often used for wrapping a function within or with additional function. So how it works? So decorators use the at syntax and are placed directly above the function definition. So example at my decorator. So define greet, we print hello, and the common use cases for decorators include one for logging. So they trace when functions are called and what values they return. And under logging also helps with debugging and tracing program flow. And part 2 use case is timing. So they measure how long a function takes to run performance. thereby monitoring what's happening. And number 3 is they help in access control. So they restrict access to certain functions based on roles, permissions, or authentication. And number 4, we look at caching. So they store the result of expensive operations, so they don't repeat, for example, using add cache from function tools. And number 5 is for validation. So they help in automation, that they do automatically check function inputs and they raise error if invalid inputs are entered by the user. So let us look at meta classes. What is a meta class? A meta class is a class of a class, or a class inside a class. So just as objects are instances of a class, so classes themselves are instances of meta classes, and they define how classes behave. So why use meta classes? So you typically use meta classes to automatically modify or validate class definition. So they are like decorators, but for classes instead of functions. And common use cases follows for meta classes. So number 1 is for enforcing coding standards or rules. So they automatically check if class attributes follow certain rules when the class is created. And number 2, they are used for auto registering classes. So they automatically keep track of all subclasses of a certain base class, such as for plugins or command systems. So number 3, they are used for code generation. So they dynamically add methods or properties to a class during creation. So when do we use meta classes? Meta classes are an advanced topic, so they are powerful but should be used sparingly. Remember, decorators are more common in day-to-day programming. Hello guys, let us look at function decorators. So function decorators in Python are a powerful feature that let you modify or enhance the behavior of functions without changing their codes. For example, you can think of it like wrapping a gift. So the original function is the gift itself, and the decorator is the wrapper or the wrapping that adds some flair or functionality around it. So for example, that's import time. This one will be imported here to scope it to the decorator, and this one is absolutely optional. So let us have our function def retry maximum attempt is equal to 3 with delay of 1 second. So the decorator. This is the decorator that retries failed function calls. So we define a decorator with a function parameter. So remember, this inner function is the actual decorator applied to the target function. And we can also define the wrapper with args and quags. So attempts is equal to 0. So we need to track the number of retry attempts. So while attempts is less than maximum attempts, so we need to retry to loop, and try is such that return func with args and quags. So this attempt to call the function except as error. So this one will automatically cache any error exception, and you will increment the retry counter. So we need to print the number of attempts, and if the attempt is exactly the maximum attempt, then so if this was the final attempt, then we say we need to erase the last exception. So we need to erase time dot sleep, and we pass on delay as the argument. So wait, we need to wait before retrying. So symbol back of strategy. So we need to return wrapper, and we need to return now the decorated function. So we return the decorator. So this is the function that will return the decorator function itself. So let us move ahead. Now let us have our example usage. So we import random module because we are going to use it sometime. At retry, maximum attempt is equal to 2. So we need to define and reliable API call. So this one will simulate Planky API. Now let us define a function that simulates a function that fails randomly, e.g. due to network issues. So if random.random is less than 0.7, then we need to raise value error that API timeout. So this one will simulate a failure, else we need to return success. So only returns success if a random chances pass. Now let us use or let us run the function, and we may retry up to 2 times if it fails. So for example, we need to print API result, and we say an reliable API call. Running our program by advanced Python concept.py, we get this result. So we find out that everything we've done has been printed here. So let me preview our function from the start. So let me minimize my terminal, and this is exactly where we started, by importing time, random, def retry function, decorator, all the way up to at retry attempts. So guys, I believe that we're going to do more examples. Let us move ahead, and I wish you all the best. Now let us look at class decorators. What are class decorators in Python specifically? So class decorators are similar to function decorators, but they are applied to the classes instead of functions, and they are used to modify or enhance the behavior of an entire class. For example, by adding methods, wrapping method classes or method calls, or registering the class somewhere. So example, we are having our add rep and CLS as the parameter, and so this decorator that adds a representation method to classes. So this one dynamically add a underscore rep underscore method to the class. For example, class dot rep method equal to lambda self, such that class dot name var self, and we need to return the class. So this one will return the modified class. Now applying the add rep or add representation decorator to the point class. You can have an example at add rep class point, and our method, we define our method with self and x and y parameters. So this one will instantiate attributes for the points coordinates, and self.x will be x, self.y will be y. Now we can have our example with a p as the point 3, 4. So this one will instantiate a point object, and we can now print the object, which now uses the custom underscore ref underscore added by the decorator itself. So if we print the point representations as p, we get the output as point x is 3, whereas point y is 4. Our output. So by advanced Python concept.py, and voila. Now guys, time to look at meta classes. So descriptor field. So and going for our example, class field. This is a descriptor for validated attributes, and we define our methods with attribute as self, type underscore, and default is none, and self.type underscore is equal to type underscore, and this is the expected data type for the attribute that we've defined, and self.default will be default. So this is the default value if none is provided, and self.name should be none. This will be set dynamically later with underscore set underscore name. So and we define the method set underscore name underscore. This one will have 3 parameters: self, owner, name, and so this it will be called when the owning class is created, and self dot name is equal will be called name, and this one will capture the attribute name. So and the descriptor is assigned to. I can also define the method underscore get underscore with the self, instance, and owner as parameters or attributes in getter. This is a getter that retrieves the value from the instant dictionary, and if the instant is none, so we need to return a self. So if it is accessed by the classes or the class, then we return the descriptor itself. Else we need to return an instant dot get self.name comma self.default. And now we can also define another method of set with 3 parameters, and if instant value comma set dot type is such that so setter I will perform type validation. We need to raise a type error. So and using f string can use expected error, so using self.type.name, so we get the type of error, and instant dot underscore this dot underscore self.name is equal to value. So which one will save the value to the instant underscore dic. We can look at meta classes, so using validated meta. So our example class validated meta with attribute type. So this meta class is the meta class that sets up a field descriptor. So we can define the method underscore new underscore with class or CLS name basis namespace as the parameters or attribute. So this runs during the class creation, and it looks through the class attribute. So for key value in name, for key value in namespace dot items, so if is instant and value field as parameters, so this means that if the value is a field descriptor, then we need to assign the field name. So value dot name is equals to key, and we need to return super dot underscore new underscore with CLS name basis and namespace as the parameters, so or the argument. So and we use the built-in type to create the new class. So let us have our class using the same meta class and descriptor. So our example class person meta class is equal to validated method. So name is equal to field and stars as attribute, age equal to field int comma 0, and then you can define underscore init underscore self name age as parameters, then self dot age is age. Now let us have our example usage validation test. So for example, try p is equal to person 21 23 20. So this one will raise a type error or invalid usage. So since name is not a string and age is not an integer, except type error as e. So this one will catch and print the validation error from the descriptor. So if we print using f advanced programming.py, you find that it is saying expected a string. So we realize that our program is working as expected. So let us move to the next section. Now guys, let us look at context managers as our subsection number 3. So context managers in general does the following. So they help in resource management, that is files, logs, among others. They also aid in timing blocks. They are also used for temporary state changes, and they also enhance error handling setups. So we need to look at class-based context manager. Context manager class database connection as an example. So for example, class database connection. So the context manager, this is the context manager for simulating a database connection. So we define the method for with the parameters as self connection string. And this we are initializing with a connection, a string. So self.connect underscore string is equals to connection string. So this one will store the connection string. So and self dot connection is equals to none, and this placeholder, this is the placeholder for the connection object. And we can also define another method, dev underscore enter underscore self, which means that it's called when entering with block, and we can print establishing connection. So this one will simulate opening connection, and self dot connection is equals to a dictionary of some parameters. So status equals to connected, so it will be simulated connected status, and handle will be id self with hashtag will be a unique identifier for the connection, and we can return self dot connection, which means it will make a connection available in the as close. So you can also define another method, a dev underscore exit, which means it has some parameters, self except type, except value, except tab, etc, and it will be called when exiting with block. So you can also print closing connection. So after using, now we close our connection. So we simulate the closing connection. So this means that self.connection will take status is equals to disconnected. So it will update the status to disconnected. So, and if exact type, so this one means that if an exception occurred, then we need to print error occurred, and we provide exact error. So we print the error message the user, and if false or none is returned, then any exception will propagate a default behavior. So let us look at the usage of the context manager. The with statement automatically calls underscore enter underscore at the beginning, and underscore exit underscore at the end, handling setup and cleanup even if errors occur. So with database connection, Postgres user password and localhost as con. So this one enters the with block underscore enter underscore is called. So now we need to print connection status, so which means con status, and this one means that inside the context block we have a connection is active. So we need also to simulate database operations here, e.g. connection con.connect.execute select, and after the block connection is closed. Running our course as advanced Python concept.py, we find that establishing connection status is connection and closing connection as we just predicted. Guys, let us look at generator based context manager. So from context, lib import context manager. So that one's inbuilt module that we're going to use. So context manager is just a temporary change. So we can look at our context manager, def temporary change with attributes as object attribute and new value. So this temporarily changes an attribute of an object within a context block. So object or obj is equal to object whose attribute you want to do some changes, and at the name of the attribute to change as a string, and new value refers to the temporary value you would like or you want to assign. So after the with block, the original value is automatically restored. So let us look at an example. Storing the original value of the attribute. For example, old value is equals to get attribute object and attribute. So we can set the attribute object attribute new value as, so we set the attribute to the new temporary value. So we try and yield. So this yield will be a control to the block inside the with statement. And finally, so which means the set attribute with object attribute and old value parameters too, which means that no matter what happens, even if there is an error, we need to restore the original values. For example usage, so class config debug is equal to false. So this means that the default value of the debug setting is false. Now guys, let us print our debug status. So original debug is config.debug, and this should print false as the output. So let us use the context manager to temporarily change debug to true. So with a temporary change, that is config debug to true, so this means that inside the block we need to debug it temporary to true. So I will change that error that we are seeing. So we need to print temporary debug is config.debug. So this one should give us a true value. So I'm getting this error because I'm having commenting issues. So with the temporary change config debug true, so which means that now the new debug will be true instead of previously false. Now after the block, the original value is restored back to false. So if we print restored debug as config.debug, then output should be true. Sorry guys, the output should be false, not true. So let me print by advanced Python programming concept. Then you find the output is false. So we started with false. After a temporary change, we went to true. Then after the restoring procedure, we still get false. Now you understand the concepts. Let us move ahead, guys. So guys, on subsection 4, we are looking at concurrency. Let us understand what's concurrency. Concurrency refers to the ability of a system to handle multiple tasks at the same time, and it is about dealing with multiple things at once, but not necessarily executing them as simultaneously. Concurring the models, they have the following characteristics. Threading, so they're based for input and output, so bound task, e.g. GIL, which is limited, and multiprocessing for CPU bound tasks. Again, another function is Asyncio, in and out, which means high level as async and await pattern. Threading, in I/out, output, input and output bound tasks. We import threading, and we also import time modules. So downloader class. So for example, class downloader. So thread safe download manager. This is a thread safe download manager, and we find the method with parameters as safe. So we this initializes the downloader class, and it creates a lock for thread synchronization. Again, it initializes a counter for completed to track the number of successful downloads. So self.lock is equals to threading.lock. So this ensures threading or thread safe operations, and self.completed is equal to 0. So which the counter to track the number of completed downloads. We can define another method as def download, so self with URL pattern. So and we need to simulate, this means that we need to simulate download task for a given URL. So time.sleep, I will give it as 1 second by default. So this one will simulate an input/output operation, e.g. downloading a file, and ensures that the counter is updated in a thread safe manner. So with self.lock, so this ensures only one thread can modify the completed counter at a time. Self.completed will increment by 1, so which means we need to print the downloaded and then URL, and self.completed over 3. So this one will print the current status of the download. Now guys, I have expanded these codes and added this main function to handle all the outputs. So we have URL for file1.com, file2.com, and file3.com. So if I can run this, and you can see the sample that is given out by advanced Python programs, and we run, we find that downloaded file2.com, this is one of 3, and downloaded file1.com, and this is 2 of 3, and lastly 3 of 3, which means we are downloading 3 files. You can change the number of outputs. So let me rerun again. Py advanced Python program.py boiler 1 over 1, 5, 2 over 5, 3 over 5, 4 over 5, and 5 over 5. So guys, let us move on to the next concept. Now let us look how to manage the threads. So thread management and execution. So example, downloader is equals to downloader function. That is, we are creating a downloader object. So this one will create threads for downloading different resources. So for example, threads is equals to threads.thread target is equal to downloader.downloader. and so my programs and args are resources. So for I in range 3, so this is a for loop through to create 3 download tasks. This is simply a for loop to create 3 download tasks. So let us print multiple threads. So starting a threaded download. So this informs that the downloads are starting. So start is equal to time, and we need to record the starting time or the starting duration. So for t in threads, t.start. So we start all the threads. We can as well wait for all the threads to finish. So for t in threads, t.join. So we can print the total time taken to complete all downloads by the following line: print completed in time minus start into decimal places. So we're calculating and we display the time taken for all the downloads. Now let us determine the time that was taken to download our files. So we find that it was 1.01 seconds. So let us look at multi-processing using CPU bound. So from multi-processing, we need to import a process queue among others. So let us define our worker function with task queue and result queue as parameters. So this will process worker function that handles CPU intensive tasks. So while true, task is equal to task.queue.get. So this one will get a task from the task queue, and if task is none, which means that it will check if the task is the sentinel value, that is none, which signals the worker to stop. So we need to break as well, and the result will be the sum of I value times I for I in range task. So this will perform a CPU intensive work by summing of the squares in this case hashtag, and by simulating a complex computation. So result queue.put result, this one will put the result in the result queue. So let us look at setup, process pool, and task management. So we need to create 2 queues, and the task queue will hold the tasks for the worker processes. So the result queue will store the result of the result of each task, and you can have an example as task is equal to queue and result will be queue. So we create a pool of 4 worker processes. Well, the process is equal to process with argument as target is equal to worker, args tasks result for underscore in range 4. So the processes is equal to process, target is equal to worker, and args are tasks, and result for underscore in range is equal to 4, which means we are creating a pool of 4 worker process. So starting all worker process. So for p in processes, p dot start. So we start all the processes. So we need to submit now task to the workers. So submit task computations to the task queue. So we use for loop for I in range 1000 and to 1005. So these are tasks are the numbers 1000 to 1004. So task dot put then I. So we print all the tasks. So stop worker from now processes. Now we need to send a sentinel value, that is none, to each worker to signal it to stop the processing. So we use for loop for underscore in processes task dot put none. So sending in none to signal workers to stop what they're doing. Now we proceed and want to look at how to collect and now print the result of what we have just been coding. So retrieve and now print the result from the result queue. So use again for loop for underscore in range 5. So we need to submit we need submitted 5 tasks. So we expect 5 results. So print result and result dot get. Now we want to join the processes, that is wait for them to finish. So we want to wait for all the processes to finish or complete before exiting the program. So we use again for loop for p in processes. So p dot join. So guys, let us look at Asyncio or high level concurrency. So we need to import Asyncio module. So async function with retry logic. So async def fetch retry with URL and retry is equal to 3. So this one is asynchronously fetching data from a URL with retry logic in case of timeouts. And we need to loop for a specified number of retries, and this case is 3. So for attempt in range 1 to retries, and to add 1, so I mean incrementing. So we need to try print attempt and the number of attempts for each URL. So we're printing the attempt number. So we need to do some simulation. So we need to simulate a network called with a timeout using async.timeout. So async with async.timeout, and this time we're using 2 seconds. So 2-second timeout for the fetch operation. So await asyncio.sleep 1 second, so which means simulate network delay by 1 second, and if no exception occurs, then we need to return the simulated fetched data. So we need to return data from each URL, and we can also handle the timeout error if the fetch operation times out. So except asyncio.timeout error, we need if attempt is equal to retries, which means that if the total maximum retry attempts have been reached, then we need to re-raise the error. So raise, if still attempts are left, then we need also to wait for a certain time before retrying. So await Asyncio.sleep 0.5 times the number of attempts, and this one will be exponentially back off the retry after increasing the delay. So let us look at main function to run fetches concurrently. So async def a main. So this is the main function to run multiple fetch operations concurrently using Asyncio function. So URLs is equal to API 1 and API 2, API 3. So this is a list of URLs to fetch data from our program. So task is equal to fetch with retry URL for URL in URL. So this one will create a list of tasks, and each will fetch a URL with retry logic, except, so we need to execute all the operations concurrently using Asyncio.gather. So result is equal to await Asyncio.gather tasks, and we need to return exception as true. So this process results and handles success or will failure. So for URL, result in zip URL and result. So, and if the instance with argument result and exception, so we need to print failed, and we pass on URL to result. So we need to print failure message if exception occurs, and else we need to print now success and we attach the URL. So you need to print success message if no exception occurred. We are almost at the end of this module, so we need to run the main event loop to run our program. So I hope you will run from your side. So I'm just demonstrating, but I hope you will run. So to execute the main Asyncio function, we need to use Asyncio.run method, which will run the event loop. So this is the function Asyncio.run main.run. So this one will run everything. So please retry. And this is the summary of everything that we've learned in this advanced Python concept. So iterators and generators, they are based in memory management, so they're efficient in data processing, and they also do custom iteration behavior, as well as they are lazy evaluators. And moving to decorators, they have the following functions that we've looked at. They modify function or class behavior, and they can do reusable cross-cutting concerns, and they also there is a composition over inheritance. And now looking at meta classes, we saw that class creation, there is class creation control, and there are also framework building and advanced patterns. So, and moving ahead to context managers, we realize that they are based on resource handling, clean setup and tear down, as well as exception safety. On trading, we looked at input and output as bound parallelism and GIL or limitations, as well as shared state challenges. Now moving on multi-processing, we realize that there is CPU bound parallelism, as well as they do process in isolation. and IPC mechanism. Now moving ahead on the last part, which is Asyncio, they include their high on concurrent input and output, and they are cooperative multitasking and assign and await. They use assign and await syntax. So guys, voila, module 7 is complete. So you've mastered advanced Python concepts. So these are the practical ideas you can work on. You can build a generator pipeline for data processing. You can also create a retry decorator with exponential backoff, as well as you can implement a threading safe cache with context manager, and you can also do benchmark multiprocessing versus threading for different workloads. So I wish you all the best, guys. Please don't forget to subscribe, like, and comment to our channel. Thank you, and let us meet in module 8.